Yeah. So what I was discussing is when I opened this question, I tried to find a formula for how do I count all the numbers whose digits are either distinct or whose digits are repeated. So I thought there will be some standard formula or some standard permutations for this that I can come across and I can utilize that fact. So when I search for that query here, that numbers with repeated digits, and when I saw this, it is just a LeetCode question. Now, if I ask you from 1 to n, you see a question from 1 to n, you know how many numbers are there which have repeated digits. If you get to know that answer, if you have solutions to this problem, how many numbers have at least one digit repeated? If I have this answer with me, can I get the answer for this question? Yes, it will be just n minus whatever has repeated digits. Okay, although in LeetCode contest, I've rarely seen this happening, that this was a kind of a different version of same question. Now, when I saw this, I simply headed on to this discussion and I found one solution, took it, modified it, and submitted it, and it got accepted. So it was like during contest, this question was kind of made easy because of that, because of it's a solution for another problem. Okay, so what is the learning from this? Yeah, guys, any learning from this? And it's not, I don't think it's only me, it's many other people would have known about this question. In fact, I saw later on the person who has solved, I think who was rank 1, he has mentioned in comments also. Somewhere in comments I saw. Yeah, he says this is the repeated question he has solved before, and he has put these comments also, and it is exactly same thing. So, but he has written, I think, a little different code than what it is. So we will talk about the approach though. It's a mathematical way of solving this problem. Okay, so coming back to how we could have approached this. So let's see. Yeah, this is again some maths involved. And there is one more area, although I still need to do a little more work on that. I need to solve this problem called digit DP. So digit DP is a category. It's a fancy name given to one topic which typically solves problems. It's like it says count numbers in range A to B whose digits meet some criteria. It is like, for example, whose digit sum is count numbers in range 1 to 12 or 1 to 10 power 12 whose digit sum is 15. Imagine if this question I give you, so it's a range question. Can we solve this using brute force? Yeah, can this be solved using brute force? You have to count numbers in a range. This, how many numbers in this range have digit sum as 15? No. Yeah, for such questions, there is a technique, DP technique called digit DP. That is what people use. And that can be 1 to n or, sorry, or it can be any range A to B. So this question to me looked more like that, but I did not go with that approach. So other approach, if that is not the approach we are taking, then what approach we can take is, imagine, let's say we are counting numbers from range, in range 1 to 1000, let's say, which has distinct digits. Let's start thinking about that separately, or rather than 1000, let me take it something other, 1 to 2435. This is what we are actually going to count. So it's a permutation question. If I ask you one digit number, how many one digit numbers are there whose digits are not repeated? This answer, I'm sure, will be straightforward, does not require any complex mathematical skills. Yeah, For one digit, there are only 9 numbers because 1 to 9 was only allowed. Leading zeros are not allowed. Now, if I ask you, how many numbers are there which are having 2 digits but no repeating digit? So when you have 2 places to fill, you simply go with how many ways are there to fill the first place? What digits from 0 to 9 can you fill in first place to create a 2-digit number? You can place any 9 digits, which is 1 to 9, you can fill. So there are 9 ways to fill first place. Into how many ways are there to fill second place? You have to keep in mind repetition is not allowed. Kumar, if you say 10, it will repeat the digit you have placed in first. Right? So if you have put first place has 9 possibilities, which is 1 to 9. But once you have placed any one digit out of that, then second place is left with how many possibilities? Can we put 0 in second place, Akshay? Yes. So what is the possibility of second place? Again, 9 possibilities. So now you can put from 0 to 9 except 1, except what is filled in first place. So you still have 9 possibilities. So total numbers possible of 2 digits will be 81. Are we in agreement here? It is 9 into 9. Only 2-digit numbers will be 81. Okay. Let's continue this. What is Shriniketa? What is that 98 you have written? Okay, let's go with third place. If you have 3-digit numbers to create, no problem, that's fine. If you have 3 digits number to create, first digit, how many possibilities for first place? 9. Second place, how many possibilities? 9. Third place is how many possibilities now? It is 8. Okay. Now, same way, if we continue for 4 digits, you will agree that total number of 4-digit numbers without repetition will be this. Okay, because every time you use 1 digit at a previous place, your one option reduces for the next place. Fair? So if these calculations we are going to use, we want to count how many numbers are in the range 1, 2, 3, 4, 5. Can I say if this is n, if n is 2, 4, 3, 5, then we have to count all 1-digit numbers without any condition. Every 1-digit number will be a valid number. Are we in agreement? Yes. So 1-digit numbers you said is 9, and you know how to calculate that. For 2-digit also, you know how to calculate that. So we can write a function which calculates this. So we can say total numbers with d digits non-repeating. This you can easily do. If this is n, you will start with this. So if you have 4 digits, you will start decrementing from this place onwards. First 2 values will always be 9. So you can ideally start with your answer to be 9, and you start from digit position 2 onwards. You can say for position 2, position less than equal to n, position plus plus, and all you have to do is you have to say answer is equal to answer into next number. This multiplication I'm taking from starting from 9. Let's take d is equal to 9, and now you are multiplying first with 9, then you will decrement. Next time loop runs, it will become 8. Next time loop runs, it will become 7. So if you see, if we pass 4 here, it will be 9 into 9, then 8, then 7. So this first part is nailed for us. This function can give us total numbers with n digits that are possible without repeating. So all 1-digit numbers are okay for this n. For this n, are all 2-digit number okay? If n is 2, 4, 3, 5, are all two digits number okay? Yes. And that also this function can give us easily. Okay, that somehow comes to be 81. For this number, should we consider all three-digit numbers also? Yes. So same way, all three digits also we can take, because up to three-digit numbers, everything is smaller than this. So it is within our range. What will be this? 81 into 8, 648. So far, these many numbers we have found. Okay. Now, can we take all four-digit numbers also? Can we consider all four-digit numbers? No. So all four-digit number does not make sense, because this is not 9,999 plus 1. If it was 10 to the power 4, we would have considered our full digit also. But unfortunately, this is a middle number. That means second part is tricky. We have to find how many numbers are in the range. Up to three digit you have calculated, but now you have to find how many numbers are in this range which meet our criteria, because those numbers are still unaccounted for. Hope we are on the same page up to this place. So our answer is A plus B. A is this. A is where A is count all distinct digit numbers of n minus 1 digits. And this is length of n minus 1 digits. If n is 4-digit number, we are saying up to 3-digit count all, and that sum is 9 plus 81 plus 648. Now for this, we have to be cautious in calculating the numbers. Okay, so here we find a range. 1000 to 2000, can we consider everything? 1000 to 2000, can we consider every number? Yes. Or if I put it this way, 1000 to 199, every number is in our range. Same way, can I say 2000 to 2400 is every number in our range? Yes, that range we have to consider. Same way, if I ask you 2430 to 2435. So we are breaking basically this number now, all four-digit numbers we are breaking in a particular range, this, and this. Okay, 2400 to, yeah, we can break it 2400 to 2430. Yep. And then 2431 to 2435. So if we can figure out a way, how do we check answer in these ranges? What essentially we are talking about is starting with 1. After 1, you have 3 more places to fill. And in those 3 places, you cannot use only one digit, which is 1. So all the numbers in this range are starting with 1. Do we agree with that? All the numbers in this range are starting with 1. Now we can use our previous computation. How many ways are there to fill this place? 9 ways. Okay, great. How many ways are there to fill this place? 8 ways. How many ways are there to fill third place? 7 ways. Okay, so this gave you the first range answer. Let's go to the second one. 2 is there, and of course there is some limit that we are putting here. How many ways are there to fill this place? Yes, tell me, how many ways are there to fill this place? Not 9, Hemant. We cannot fill 5 at this place. Remember that. So there are few options. You can put 0, you can put 1. Can we put 2 here? No. So we can put 0, we can put 1, we can put 3, we can put 4. So there are only 4 ways to fill this place. Yeah, 2400 is inclusive because we did not. Yeah, 2400 we should include. Leading zeros will be included. So here I will put 0, 1, let's say. Okay. So basically Now you see that we are breaking the range and we are counting. So this place has only 4 options. How many options are there at third place? How many numbers you can fill in third place? Not 3. Can you put 9 also? Can you put 8 also, Kumar?
Sir, isn't it 5, 0, 1, 2, 3, 4, 5 digits?
Where?
The after 2. Oh,
After 2, this
okay, we can't put 2.
we
Sorry.
can't put 2, yes. So we can put 0, 1, 3, 4.
Yes.
Yep. Okay. Or even if we want to break, ideally we can, I think we can be, just if we want to be on safe side, what we can do is we can break the ranges in such a way that we can break it up to 1 less than the next digit. Next digit was 4 here. So go with 300 up to 2000. 23XX will be safe. Is that correct? Up to 2399 will be safe. So we are restricting ourselves to 1 less than 4. Then 24002, we can go with 242. Up to here, we can go with up to 2 only, 2429. So we are actually fixing the next character is 3. So let's go 1 less than that and put a 9 after that. So this way, if we break, I think it will be much simpler to do that. Okay, so this is something that in this range, you have to come up with a range. You have to write one more function for doing this and then compute the answer. Okay, so this is something I can give you the link to the help I took from during the contest, the other question that I was showing you, and that was using this technique. And okay, I'll have to open that again. I don't have a link to that. Go back. Number with repeated digits. Yeah, so idea was this. This is one approach kind of to solve the problem. One more approach for this. Kaushik, you were pointing about the permutation based approach.
That was for third problem, sir.
That was the third problem, not for this. Okay, so this is the link here just for this idea that how to break it into 3 parts. And I'm sharing that link in the chat here. Okay, so that was the discussion. And one more thing I will recommend everyone to do after the contest gets over, you have access to everybody's solutions available. Sometimes when you go over, look at other people's solution, you see people use a lot of shortcut ways of solving problems and you get to learn a lot from there. So refer to the solutions, at least top solutions, people who completed very fast during the contest. Okay, I remember now, I have seen somebody's solution. Kaushik, this also used a permutation based solution, which was very intuitive, very nice. I can talk about that solution. Yeah, so looking at other people's solution after the contest gives us a lot of learning. That is an interesting thing that we all should do. So coming back to another approach, which was again a permutation based approach. So imagine if you can write a function which says generate permutations. In this, digits were not repeated. So, and you're creating a number up to 10 to the power 9. So what is the maximum number of digits that our number can have? Because maximum number of digits, 10. Right? So 10 digit numbers we are talking about. So we need permutations of, can I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We need all the permutations of this. And only those permutations it will generate, which are having unique digits. If you generate all the permutation of this, you will get all numbers which have unique digits, because every digit we are reusing once. So it is like generate all permutations. permutations of this. Now question is, how many permutations will this lead to? How many permutations we will have? For 10 size array, how many permutations we will have? 10 factorial. And how much is that actually? How much will that be actually? 10 factorial is how much is the value of that? Okay, it is 362,800. In 10 power range, it is 10 to the power 2 to 4 to 6. Can I say upper bound is like 10 to the power 7? So if we generate all the numbers, all the permutations of these numbers and store it in an array, generate all the permutations is first, sort them and basically convert them to int and sort, convert them to int. For example, if I convert this to int, leading 0 will go away, and sort them, convert them to int, sort in array and sort them. Now, if you have an array of all the numbers, let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have 10, 12, 11 will be missing, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 will be missing, 23. If I have a sorted array and I ask you, tell me how many numbers are in range 1 to 25, let's say. If I ask you 24, 25, 26. If you have to count those numbers, can we perform a binary search on this array and find out what is the index of 25? Yes. And if you do the binary search, if you get that index, will that help you get the count of numbers? Yes. So it is like pre-compute and generate all the numbers once, keep them sorted, and to answer this query, you do a binary search. Binary search will work in logarithmic time. During the contest, one thing that was there in my mind, I did not pay attention to conclusion that n factorial is sufficient. Idly, when I was thinking of one more alternate solution, I was thinking that numbers will be huge. But the beauty is, even though the range is 2 into 10 to the power 9, the total numbers which are going to be the output will never exceed 10 to the power 7. And those numbers can be stored in a list if you take a global list and store. So that later on, when I saw the solution of this person, Awise, I think, yeah, Awise has used that tricky solution. And here he's using built-in functions of Python to do the binary search. So that was one more good approach for solving this problem. Okay, so one takeaway is, yeah, permutation based problems, usage of permutations, built-in permutation function is something that is my takeaway from this contest, that probably people should do more problems on permutations, and that gets useful in solving problems. Cool. That's what we had for today's discussion. Any doubts, any questions from anyone? Okay. No doubts. Then cool. We'll stop here.